All right. All right, guys. Happy 2025. Good to see all these faces and a big thank you for Larry for drawing in all these people. This is just awesome. I hope everyone's staying warm in this rather chilly days we've been facing in New England. Um, and I hope everyone had great holidays, more importantly. So it's very nice to see everybody. In terms of announcements, because it's very early in the year and not a whole lot of activities going on, I can only speak to um, one event that maybe some of you may care about. For you ham people, there in Whitman, there is the Amateur Radio Club Winterfest in, of course, Whitman, Massachusetts. And that'll be on, I think, Saturday, January 18th, and it'll be from 9 to 1 p.m. So I'm sure Ross can, add more color to that in case you are curious about this. But that's the probably, oh, actually, strike that. There's one additional one. For you vinyl folks, there is the Music Expo's vinyl record show in Woburn. And so if you're looking for some vinyl, or I've actually never been to one of those shows where they have other stuff. It wouldn't surprise me if they uh, they do. And that's from I think that's Sunday, January 19th from 10 to 3. So something to look forward to in case you guys are yearning for something to do over the until the show all the shows start kicking up. Um, but I think that is it. Um, Bob, did you have anything you wanted to say to the crew here?
I'll just, excuse me, just remind the group about our New England Vintage Electronics Expo 8 on March 2nd. It's coming up at Castleton in Windham, New Hampshire. So we're planning for that now. As you know, it's a new term for me, his second term as president, and we have a new slate of officers and directors. So we're looking forward to the NEVE 8 and hope you'll all attend. One of the good things is we have a silent auction coming up in the event, and there's have quite a few items this year, so that's one thing to look forward to. So I hope we see you there.
Indeed, indeed. Thank you, Bob. Oh, and one other thing, if for those of you who don't forget to renew your membership if you need to do so, just go to the website, but you guys know by now the drill. Um, and I think that's it. Is there any announcements anyone needs to make that we should be aware of that we haven't covered before I hand off to Larry? I guess not. All right. Well, there's still time at the end if something comes later. Larry, I'm going to hand off to you, and in fact, I'm going to pin you so that for recording purposes, I'll be able to see you at your maximum here. Wait a minute. Oh, there you are. Um, I'm going to pin. That way we get to see you maximum. So Larry, this is all yours.
Okay, let me see if I can figure things out. But first, for those of you who have never met Elaine, that's Elaine.
Hi.
My lovely
Hi,
48.
Elaine.
Yeah.
And she comes to all the shows with me. How could you ask for a better wife,
Yeah.
you know?
No, you're awesome. I will say that.
So she's going to be manipulating the camera here while I do my thing, have my way with the radio. So I got to figure out on Zoom how to flip the camera here. Let's see. Anybody help me out here? I'm on an iPhone and I want to flip the camera.
So you should be able to flip the camera directly, Larry, I think.
Yeah, there's a button at the
Yeah,
bottom.
there's a button on the screen.
Okay.
Right.
Well, I'm
Reversing the video.
seeing mute, stop video, participants, chat, reaction, share.
It's the one with the two arrows pointing.
Yeah, I'm not seeing.
Yeah.
You might
Show me again if you don't mind. That was a little fast. I saw it briefly.
Lower right corner, maybe?
Oh, well, let me see. Lower right corner.
Right.
Yeah, see,
Uh,
it flips it.
It's got two
No.
circular arrows.
I don't get that.
Wow, I wonder if you have an older
Yeah,
version.
maybe if it's an older phone, you have to kind of just tap on the actual picture on the
Right.
screen, and then it'll pop up, and then you'll be able to rotate. It's
Yeah.
not.
Well, I tapped on the picture and I get the tiled view of all you guys.
Hmm.
Hmm.
I thought you did it for a second. I thought that button in the lower right was it.
Yeah.
Yeah, lower.
I bet it's the app on the Zoom that's stopping it from doing it.
Mm.
Shouldn't, because that should just take a video feed.
Well,
Let me
what
see.
we can do is turn the camera around and we can use that for feedback. Yeah, that'll work rather than wasting time.
Okay.
All right, because I'm connected with a computer up here too, so I can see
Oh, okay.
what's on the camera.
Oh, good. Okay, then that
It
works.
makes it a little harder for Elaine.
Yeah, okay.
Okay, so this is the victim here. This was donated by a lady in Rochester, New Hampshire. I picked it up we picked it up on our way to the Spring Brookline show last year. So I'm going to take the knobs off and take the chassis out, and Elaine can hold the camera while I do that. I've already loosened things up a little bit.
I was gonna say, where's the claw hammer?
That's the last resort. 4 screws to take out here. The radio is unplugged, by the way.
Right.
And before we get started, I want to say something about safety. I'm not making any recommendations here for anybody. You know, we all are responsible for our own well-being. Don't take anything I say here as a recommendation of how to do or not, well, mainly how to do anything, because it may not be the safest way, but I've been doing this a long time. I know where the electrons are hiding. And I'm going to take a few precautions I'm going to show you, but that work for me, but I'm not going to suggest they're going to work for you. So
Have you removed both your watch and your wedding ring? Is that how that goes?
well, I haven't worn a wedding ring for years.
Okay. Usually if you have the watch on one hand and the wedding ring on the other, then that means the path of direct current is through the heart. So that's probably not a good thing.
That's not a good thing, but I wear neither, so we're safe there. So a little dusty in the cabinet, but no mouse remains or anything nasty like that. I'll take the camera from you for a minute. So this is the set, a little dusty.
Mm-hmm.
Those people who printed out schematics will know that it's got 3 loktal tubes and 3 octal tubes. It's basically an all-American 6, an all-American 5 with an RF stage, using 150 milliamp series string tubes, suicide chassis. I'm going to give the phone back to Elaine. So the first thing we're going to do is a visual inspection. And I know there's plenty of experts in the audience here, who know as much or more than me, and everybody's got a different way of doing things. There are a bunch of right ways, and there's also a bunch of wrong ways to do things. And I hope mine is one of the right ways, but there's a continuum between right and wrong, absolutely right and absolutely wrong as well. So visual inspection, the line cord is very scary. John talked about one of the Zeniths, or was it RCAs, I guess, that he wasn't going to mess with because it had a very scary line cord. So I'm going to clip this off and get it out of here. And let's see. We're not going to save it, so I can, to my heart's content. Nothing worth saving on this line cord except for the plug.
Yep.
And maybe the tie wrap if you're hard up. Okay, so continuing the visual inspection, we're looking for wax paper capacitors that are dripping wax. Looking for discolored resistors.
Especially the one between the line and the chassis.
Let's see, does this have a resistor between the line and the chassis? No, it does not.
No, the capacitor. With
Oh, the
A death cap. Yep.
C10.
Yeah, it's here. That's this guy.
How about that one just by the speaker?
This one here?
Yeah, that one looks a little discolored. Nothing wrong there?
I'm not going to suspect it yet. That is the one between the wiper of the volume control and the grid of this 12SQ7. It'll upset the grid bias if it's leaky, but the set will probably still work with that if it's not too bad. Well, actually, even if it is, it probably will still work. Next thing we're going to look for is some of these sets have rubber insulation on the wires. These seem to be cloth. The rubber tends to crack and fall off, but I'm not seeing any of that. The wires feel waxy, so that's kind of good. Wait, there's some rubber insulation there, but it doesn't look like it's creating any shorts or really falling off. There's this questionable place right where I'm pointing. There, I don't know, you can see it. It's green insulation, but
yep.
It's there's a spot on it, but it doesn't appear to be shorting to anything. So we'll leave that alone for now. Anything above the chassis I missed? Not really. Also looking for any previous work that might have been poorly done or done wrong. Nothing's jumping out at me there. And anything else that reaches out and grabs you, I'm not seeing anything. So that's the visual inspection. I did say I tested the tubes. What I found was that the mixer tube at 14Q7, the oscillator section tested good, but actually, I should call it more properly the converter tube. The oscillator section tested good. The mixer section tested very weak. Transconductance was supposed to be 500 and it was testing around 150 or something. I don't know if that's going to stop the set from working. If it was the oscillator section, I'd be more worried about that. Because I've found quite often tubes can be way, way below the GM spec and still play in the radio. But we'll find out. Unfortunately, I did not have a spare. I don't have a lot of 12-volt loctals, and I had none of these. The octals, I all have plenty of spares of. Let's see, if we tilt it this way, it probably would be better. So now I'm going to do a few resistance checks. Just to get an idea. Okay, I'm going to first of all go across the B plus line, which easiest way to do that is the cathode of the rectifier tube, the 35Z5 to chassis. And I think I checked this out before, but chassis is ground. So that ought to work. So Elaine, you want to come over here so you can show the meter? Walk around to the other side. Okay, so we're looking at pin 8 of the 35Z5 to ground. And I'm not seeing anything. That's with them shorted together. I'm on the highest resistance scale on the Simpson 260. And I'm also going to go to the negative of the filter capacitor here. Whoops. Okay, now we're getting something. Maybe I didn't. Okay, now that's the filter capacitor charging up to 9 volts from my meter. All right, so maybe the chassis, maybe I'm misreading the schematic. The chassis must be isolated from ground. Okay, we're down to about 200K ohms, which is pretty good. I mean, nothing's going to get too hot if it maintains that at full voltage. That's not to say the filter capacitors are good, just says they're not shorted or not excessively leaky at 9 volts. So we're down to about 300K. Keep in mind, these capacitors haven't seen any voltage on them for God knows how long. All right. So that's a reasonable result for a simple resistance check. Now I just want to see if, make sure the line, oh, I already cut off the line cord, but that's okay. We're going to have to connect a new one anyway. So I'll go across where the line cord connects here to the switch. The switch is on, so you should see that. That's the filament string. It's off now. It's on. So that looks reasonable. Okay, and if we can find the leads easily enough, I'd like to check the primary of the output transformer. This output transformer is kind of strange. Usually there's only 2 leads to the primary. They did something fancy here. Where do those leads come through the chassis here? Okay, here they are. Is this them? Well, let's look at the schematic where we can pick them up. Okay, if we go, obviously one is going to go to the plate of the 35L6 output tube. One of them is going to go to B plus, and then another one goes to B plus 2 through a couple 470. I'm not, okay, all right. I heard something. We heard a noise here, and it wasn't from the radio, it was from the phone. Okay, well, let's just go from B plus to the plate of the 35L6, which is, yeah, here. So that'll be pin 3 of the 35L6. Or 50L6 rather, sorry. Same difference. Okay, yep, okay, we got continuity. Resistance, it should be pretty low resistance. Oh, and I'm hearing stuff out of the speaker, so that means the output transformer is good. I'm getting about resistance wise about 1100 ohms. So that's reasonable.
That's right.
So looking good so far, except for that nasty line cord. So I'm going to just quickly tack in Can we come over there? I bought this soldering gun at a ham fest not long ago. My good old Weller bit the dust. And I like to use a gun because it heats up fast. Otherwise, we'll be waiting for my iron to heat up. Okay, so far so good. Just taking off the stubs of the line cord I cut off. Okay. Now I've got a polarized line cord here. And okay, let me take the camera for a minute. Why? Oh, I see. I should have left the camera with the lane. Okay, so what I've done, boy, this is hard. Here, I'm going to give the camera back to Elaine because I'm not. Okay, so let's see here. Okay, yeah. All right, so I've marked one of these with black. That goes to the neutral pin, and this is the hot pin. And after I did that, I realized that's exactly the opposite of what an electrician would do, because to an electrician, black is hot and white is neutral. But anyway, that's the way I did it. And as long as I know what it means, we're cool. So I'm going to tack this in where the other line cord was. I'm not going to do a permanent installation, but I may get fancy and put them through the holes here and back the chassis.
That's the root of why engineers and electricians don't get along, you know, the difference in wire colors.
Yeah. Yep. So this is, I want everybody to realize this isn't a permanent job here. This is just so that I can save time in the video and not waste everybody's time making it look pretty.
I'm having difficulty waiting for the changing of the filter cap.
Well, we're not going to do that unless we absolutely have to tonight, because that's like you say, we'd be here a long time.
Not to mention, Larry, you can spill over to another meeting if you so choose.
Yeah.
What about also checking the pilot lights, pilot bulbs? That maybe I'm just having a mental block looking at the schematic, but it seems like if the pilot lights are missing or burned out, that rectifier circuit might act a little differently than if they were in place. Or is that just me reading something incorrectly?
You're a great straight man, Noah, because I saw that on the schematic, and unless I read the schematic wrong, it says that the tubes won't light if a pilot light is burnt out. And when I checked that out, and that wasn't the case. But I did find one of the pilot lights was open, and I replaced it. I didn't have the exact replacement. It's like a 3.2 volt or something at
It was kind of weird.
At 150 milliamps.
Right.
So all I had was a number 47, which is the right current, which is the important thing, and 6.3 volts, of course. So,
Well, you can get away with just one bulb instead of two bulbs with that.
But it looks
yeah,
like
well,
the schematic looks like they're in series, though.
Yeah, right. So they'll add up in series. They'll add up to 9 volts instead of 6 volts, which is not going to upset anything. They'll just be dimmer than they should be, especially the number 47.
Unless somebody plays a trick on you and puts a 35Z4 in there and didn't have the tap in there for the light.
Yeah, well, I checked that out. It's a 35Z5.
I actually got a radio that someone put a 35Z4 in there. I spent the next hour trying to figure out why. It's like, why am I getting 6 volts out of pin 3? What's going on here? Oh, duh.
I'm going to actually put this in the hole here because I can see it's not going to cooperate otherwise. Okay, let's see if we can get this soldered now. You know what? I've got this handy little device here. That's going to be helpful. Yeah. The tip on this soldering gun is not great. I tried to clean it up, but there's only one little place on it that wants to take solder. I may have to end up heating up the iron after all.
So the line connection to the plate looks like two paths, right? One of them through the pilot lights and the other through the center tap of the filament.
Oh, okay. In that case, my results make sense. And that's the normal way to do it, actually. So that doesn't happen. You'll still have a radio.
If the lights go out, right?
Yep. Okay, so I think we're good here. Now, what I've got here is, and if I'm being too simple, I know we've got all different levels of experience here. Okay, I need my video back. All right. This is what's known as a dim bulb tester. It's just in my case, a 40-watt bulb in series with, I'm going to put in series with the line so that we can gently reform the electrolytic capacitor, give it voltage. And in order to do that, I'll give you back the camera. In order to do that, I'm going to pull the rectifier tube because I don't want the heaters of the tubes lighting up for a couple different reasons. And I'll explain that in a minute, but I'm going to replace the rectifier tube with a solid state diode that'll plug in, the anode is wired to pin number 5, which is would be the plate of the 35Z5, and the cathode's connected to pin number 8, which is the cathode of the 35Z5. So two things are going to happen here. We're going to start recharging the filter cap even if the voltage after dropping through the dim bulb is very low, because a typical indirectly heated tube rectifier like the 35Z5 doesn't even start to conduct until you're up about 70-80% of full voltage on the heater. And the other thing is I want the dim bulb just to show me leakage through the filter capacitor, and not, it's going to light quite brightly if we're sucking 150 milliamps to light all the tubes. Since it's a series heater set, plugging this in is going to break the chain and we're not going to light up any tubes. So let's see if we're ready to go here. I will say, just to make things more exciting, I'm not using an isolation transformer, but I wired the polarized plug-in so that as long as I don't turn the radio off, the chassis will be connected to neutral. And I can check that before we touch anything. So I'm going to plug it here.
There's definitely, excuse me, there's definitely a capacitor on the schematic between the chassis and the line. C10 there in the middle. Okay.
Yeah, I found it. I found it. Yep. I wasn't arguing that. So I'm going to give it voltage. Elaine, maybe I should turn off the light for the dim bulb. Yeah, why don't I do that? I'm going to turn off the main overhead lights for a minute.
Get the whipped cream ready.
And the ventilation.
Okay. Hour now. Watch the bulb. Uh-oh.
Uh-oh.
I saw a flash of the pilot lights. I'm not seeing anything. Let me make sure that I didn't. Well, No, I think we're good. Let me see if I have DC volts. From the
Is the dim switch on?
Yeah, the switch is on. Oh, okay. Yeah, so we're powered up. We got about 150 volts DC at the cathode of the diode. Filter capacitor hasn't exploded. Not even getting warm. And the light's not lighting, so that's a pretty good sign. Let me show you something here. I'm going to temporarily put the knob back on the shaft here so I can turn it off. This is a neon bulb tester, okay? I'm going to put one side on the chassis and hold the other one. You'll notice the bulb is not lighting. Now, I'm not going to touch the chassis when I do this, but if I turn the switch off, now I don't know if you can see it, but the neon bulb is lighting dimly.
Yep.
See,
Yep.
my lovely assistant confirmed that the neon bulb is lighting dimly. Okay, I'm going to turn it back on so I don't shock myself here. And the reason for that, I wanted to explain to those who may not know, with a suicide chassis set like this, the use of a polarized plug doesn't save you, okay? Because it's a damned if you do, damned if you don't situation. If you hook it up one way, the chassis will be live when the set is on. But that same connection makes the chassis dead when the volume is turned off. If you hook it up the other way, the chassis will be dead with the set on and live with the switch off, the line switch off. And the reason why the chassis is live with the line switch off is that there's a, a path of continuity through the tube heaters. So, and they didn't have to wire it that way, but they did it because if they wired it, we'll call it the right way, the safe way, then you would have, you know, 100. Am I hearing something?
I hear it upstairs. Noise upstairs.
Thought I heard something. That's never a good sign when you hear noises. Could be the line capacitor. We'll know in a minute if it's the line capacitor. But where was I? Okay, so if they wired the line switch the safe way, which would, if you used a polarized plug and wired it so that the chassis is dead when the set's on, it would also be dead with the when the switch is turned off. Then you would have full line voltage on the switch, which is in close proximity to the volume control, low level audio, and some of that AC would capacitively couple into the grid of the first audio tube and cause hum, 60 cycle hum. And the manufacturers thought, oh, we can't have more than 2 controls on a simple radio like this. Having a minimum number of controls was a selling point. So instead, they opted to keep the switch on the volume control and safety be damned.
Well, and it's another reason, just as a general rule of thumb, if a radio like this comes with wooden knobs when you're playing with it on the bench, I always reinstall the wooden knobs.
Yep. Yeah, that's a good point. I'm not feeling the filter capacitor heat up excessively. I'm not hearing any obnoxious noises. So I think, there's no light on the dim bulb, so it's not drawing any current that we can see. Okay, so I'm going to kill the voltage at the power strip here. Take out a rectifier diode. Put back in the 35Z5 and see what happens. Everybody ready?
All right, make it so.
Right. Here we go. All right, so that's the filament current going through the tubes.
So what do you think launched the pilot lamps?
I think, well, we certainly didn't lose the pilot lamps. They're glowing.
Oh, okay. I thought you said they flashed before and went out. I thought you popped them. No, I see them glowing now, so that's good.
They did flash and go out. The only thing I can think of is
So,
the only thing I can think of, we're getting some noise out of the speaker there. And I'm still going through the dim bulb. The only thing I can think of is, even though we couldn't see the dim bulb, it did warm up and its resistance did increase, and cold,
Oh, okay.
First applied voltage I don't know. The pilot lamp and then
something to do with how the rectifier replacement thing is wired? Because it doesn't look like you'd get any current through the lights unless you had something on that heater connection.
Right. That part of that schematic is weird. Maybe that's just the way they all are, and I haven't run into it before. But that kind of
It has
puzzled me.
it has the two lights in parallel with half of the filament.
Right.
So that's what gives so half of the filament isn't getting full power. It's sharing it with the lights.
It looked weird to me, but
well, yeah, that tube wasn't in when we did that, though. The diode was, so the filament circuit wasn't there. Maybe, I don't know. That's a mystery. We'll have to think about that. If anybody has any ideas, maybe Bob will get a prize. I don't know.
Or just reflection off the dim bulb, maybe.
I didn't see any light from the dim bulb when I fired it up. I'm going to go right to line. We're going to see if this thing makes any noise besides any interesting noises. Let's put it that way. Oh, we're getting some motorboating of some sort.
You may want to try cleaning the pins on those 3 loctals.
What's that?
You may want to try cleaning the pins on the 3 loctals.
Okay.
They have a tendency to get weird if they haven't been used in a long time. And if they get any dirt on them or anything, then they will not work. Or they'll work funny.
Yeah. There you go.
Did that change anything?
So that would be a candidate, that one right there.
I would also maybe try lubricating some of the shafts on the tuning dial before you break the dial cord if it's been stiff. Don't ask me how I know that.
Been there too.
Good idea. Well, I think what I'll do is take it over to the air compressor, blow off the dust, and then do that. It's receiving signals, but it sounds like the IF stage may be oscillating because we're getting all kinds of obnoxious noises that shouldn't be there.
Could be a bypass capacitor.
Yeah, it could be a lot of things.
You know, it's really funny if you read the footnotes of the schematic. It says there's a little thing in the bottom of the paper that says uncontrolled oscillation, a 470 k ohm carbon resistor soldered across the secondary of the first IF transformer will correct this condition.
Okay. Yep. So the IF is oscillating and they're DQing the second the first IF transformer.
So it's funny they would actually take the time to type in the 470 k ohm carbon resistor being soldered across the secondary, but they didn't do it. They just wrote about it. It's like, you know.
Yeah.
guess
Yeah,
they
I
saved
see that
10
too.
cents
And
per radio or something by not putting it in.
I see that too, and I remember reading that. See, I have my copy of the schematic too. So I'm going to take this over to the compressor, blow the dust off, and do that lubrication of the tuning shaft.
That's good because I really don't want to watch you try to restring the dial cord.
Like,
Want to watch me restring?
See some.
Yeah, it's
I
generally not a
might,
5-minute job.
well, try a German radio.
Yeah, where's that little spring? Is that a, you know?
The air compressor is noisy.
Good time for
Thanks for audio peak limiting.
So I think the light bulb flash, Steve and I came up with this. Steve did, the only path to B plus was through the light bulbs without the filaments in place. So it was the charging of the capacitor.
Agreed.
I know I restored that same model, and those dial lights had a delay on them. When you first turned on the set, it took quite a while just for the bulbs themselves to come on. Almost until you heard sound come out of it. Then the bulbs would light.
When the filament's cold, the resistance is low, so that.
Yeah.
But you'd think all of the resistances would be low.
Well,
But
the reason that does that, Greg, is because until some of the current going through those bulbs goes to the B plus. If you look at the diagram,
Yeah,
it's only
really
through part of the filament and through those bulbs that the anode is connected. It's not connected anywhere else. So until the filament of the 35Z5 warms up, there's no DC, there's no flow from the anode to the cathode, basically. So that's one of the reasons why that does that. And in a way, it saves kind of the bulbs because they come on slowly.
Right.
Now,
Most
one of
of
the
those lights, they come on real bright and then they get dim and then they come back to life again.
Yeah. Now, if you've ever had a bad filter capacitor, because I've seen this happen before where the filter capacitor is leaky, very leaky or shorted, what'll happen is you'll turn the set on, the bulbs will come on, and as soon as that filament warms up on the 35Z5 and it starts conducting, all of a sudden the bulbs get bright, 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 then they pop.
Right. Yep.
And that's because of a bad filter capacitor. It's just kind of a telltale thing.
That's called a burn bulb tester as opposed to
It's not a dim bulb, yeah.
Very good. Very good, Noah.
And that's why sometimes you got to watch out for those 35W4s and 35Z5s because when you test them, you can
They
have
test
half of a filament burned out and it can
Right.
still test okay in some testers, but you
Right.
go to put it in the radio and your bulbs won't work and your current flow won't be right and it'll be a kind of a mess. So, um, that's one of those things with those. It's not a center tap on the filament. It's like a tap at 6.3 volts or something to that effect. So it's
Right.
I always use a meter or some type of tester to usually an ohmmeter to check those because like I say, a lot of tube testers will test them okay when half the filament is actually gone.
Sure. I've been there on those too. Yeah. Had a few sets like that. A lot of times I've had the resistor be bad too, right before the pilot light,
yeah. Yep.
and that'll,
It's weird that they're like using part of that filament like as opposed to a power transformer, an input power transformer with a separate winding for the
Mhm.
pilot lights. Kind of clever, but kind of confusing to some of us.
But it did save the cost of a transformer.
Yep.
I think one of the unique sets that I had donated this. It was an RCA Victor. I don't think it was, I think it was the last show before we went to Castleton. It was a Bakelite set that I had donated for the silent auction. And it was basically an All-American 5, but it had a ballast tube. And the only purpose of the ballast tube was for the pilot lights.
Wow.
And I said, wow, uh, I mean, wasteful by today's standards in terms of energy, but
Brute
uh,
force engineering.
yeah, it's very, very interesting.
Maybe they wanted to claim an extra tube, but there was a phase where that was the way a marketing ploy.
Ah, very good
Yeah,
point.
There you go.
they
Yeah.
called it a 7 tube or a 6 tube or whatever, even though it wasn't a tube.
I worked on a set where once I forget the model, but it used 6H6 for a second detector and a 6P5, I think, something like that for the first audio. And they could have just used a 6Q7 or 6SQ7 or something and saved a tube, but they didn't. So I did drop some light oil into the bearings there on the tuning capacitor. So anyway, I guess the next step is just to try to.
Now you can fire it up and you can turn up and down the dial without breaking the string.
I don't think I need to turn it up and down the dial too much. I'll find a station and leave it there.
Can't remember how many old movies I've watched on TV that had that radio in it.
Hmm.
Yeah.
a radio always seems to be, especially in like 50s movies, like even if they're not listening to it, there always seems to be a radio in the background.
Mm-hmm.
Earn them. But as Benny points out, the future of the DOT investigation is
There you go.
All right.
obviously is, does it still have a life after January when we have a new
Hey,
administration?
lubricating the shafts, even cleaned up the sound.
Yeah, look at that. Wow.
Amazing.
I'm a genius.
Well, it must be that mystery oil.
Yeah.
Ship it.
It's a Zenith.
That's right. Ship it.
Very noisy. Something's making a lot of noise.
Are you in your shop in the basement? How many fluorescent lights or CFCs do you have, or CFLs, whatever they're called?
Yeah.
Yeah,
None.
yeah.
None.
You're on a Zoom, so it must be the Wi-Fi.
No, it's not local noise. It's the radio making it. I run radios down here all the time, and they don't make noise like this.
Larry, what does the noise sound like?
Like this.
We don't hear it.
Yeah, we can't
Yeah.
hear him. Maybe the
When you were on
sensitivity.
when you were on the station, it just sounded like a pretty
Yeah.
decent radio. We don't
Yeah.
hear
Yeah.
the other noise that you're
But-
hearing.
The Zoom might have its background noise
Yeah.
limiter turned
Right.
on.
Yeah, it may be suppressing some of that. That we can hear.
Now something's going into oscillation, probably that IF thing.
Hmm.
Yeah, so
It's that low transconductance on that converter tube that you didn't have a spare of.
Maybe.
That's
I
that's
don't.
I mean that's the
I
that's
doubt-
the law.
I doubt that would create noise and oscillation. It seems to be very sensitive around the first IF tube here, the 14C7.
Hmm.
I say IF, I should just say IF. I'm used to working on communications receivers with multiple stages of IF.
For grins and giggles, you could take the two 14C7s and just reverse them
Switch them. Yeah.
and see what happens.
I can do that. I think the one problem is dirty contacts.
Well, switching
Don't you-
them, if you switch those
Don't
two,
you-
they'll get cleaned while you're doing it.
Yeah.
Is it a dirty pin or is it a dirty socket?
Well, it doesn't matter if I put a little deoxit on the pins here and plug the tube in and out a couple times.
I like the idea of switching them.
Well, I can do that too, but I forgot.
Always change at least 3 things at the same time so you never know what actually fixed it.
There you go.
Right. Noah's law.
Yeah, swap all the tubes.
No, not all. Well, you're not really swapping, I mean, you're
Yeah.
just changing positions here. So
Right. Yeah.
I'm going to do both of these sockets just for shucks. Well, since I don't like to change more than one thing at a time, I'm going to go back in the same socket after we clean these a little bit. Let me.
I was just trying to share some of my best practices with the group.
And we appreciate it.
Yeah.
We appreciate it. I think I missed a couple over here.
Feel free to stop by to Honest Noah's Very Used Radios and pick up a expertly fixed piece to take home.
Texas is a long way.
Yeah, I know.
Maybe he delivers.
Ugh.
There we go.
I deliver every July about as far as Carlisle, Pennsylvania.
Yeah, there you go.
I'm gonna just put these in and out a couple times and rock them a little bit.
Our octal tubes are okay. They just need a little more attention. That's all.
Yeah, and it was kind of a neat design. They didn't have a long. They didn't enjoy a long time of popularity, but
There's not a Philco radio that I know of that don't have at least one 7B7 in it. I must have probably about 30 7B7s in my basement because I know I'm going to have Philco radios coming across my repair bench.
well, any Philco radio from the 20s or early 30s won't have a 7B7 in it.
Yeah, that's right.
Okay, so let's see if that did anything. Now we'll be completely dead.
Yeah, you broke it. Now it's no longer intermittent.
Right.
That's the thing. At least maybe it's just begging you to swap those tubes.
Now it sounds like the IF's oscillating really good. No signal. Oh, you know what? I misread a C as a Q.
Oh,
There are some things you just don't admit to.
I thought I was going to say something like, "Oh no, I used my Homer Simpson meter."
If you're looking at a 50 or a 60 or whatever year old radio, I bet the C and the Q are probably very similar on the glass of a tube like
They
that.
probably look darn close unless you clean the dirt off the top of them.
If you cleaned it, then they'd be saying nothing.
Yeah, exactly.
Well, if it's a Philco tube, the numbers wipe right off.
Yeah, exactly.
If it's anything other than a Philco, you stand a chance.
So what I did was I thought I was putting the tubes back in the same socket, but I put the Q back in the C socket and the C back in the Q socket.
It's not one of Noah's laws?
No.
Okay.
I would have taken out the two C's.
Oh, okay.
Touch the Q. Oh.
Yeah, Hills.
Now, first and foremost.
Still making a lot of noise.
Is the noise constant or only while you're tuning?
It's constant. It takes a strong station to overcome it.
Still could be your filters.
Yeah, it could be.
Or any one of a number of the wax paper caps.
Yeah, that too.
I want to speak with Brian Pratt about the fall of Justin Trudeau.
We ask him what led to Trudeau's resignation and where Canada
That's pretty
goes.
clear.
I've got a radio that does that. You know, it's like I can't get any good reception unless I hold on to the antenna.
Announcement is leading the country. He'll be stepping down. As Prime Minister. The decision came after years.
Well, at least it doesn't make noise and go on and off when I wiggled that tube anymore.
The pins sound like they're making a good contact now.
Yep.
Yeah.
There's no smoke coming out. Leave it on for a day or two and let everything reform everywhere.
Well, I'm going to you may not have got this, but
reverse pins 2 and 3.
I'm typically not a wholesale replace capacitor guy, you know.
Oh, come on. Well, one's a repair and one's a restoration.
Well, some would say, not necessarily me, but some would say that replacing all the parts isn't a restoration.
Not all
It's
the
a repair.
parts, just the wax paper capacitors and the electrolytic.
The electrolytics are always a good thing to replace because electrolytics don't have.
You didn't mention any kind of loud hum or anything, so it sounds like that one's at least hanging in there for the time being.
Yeah, for the time being the operative phrase.
I was looking on the schematic, C3, the 0.05, is that to hold the AGC down? I'm just looking if it was open, whether that would cause the oscillation. It's over on the left.
So
C3.
Way on the left.
Here?
Yeah. If
I can't. Yeah, my
I see it.
If you follow one of them, it's to the ground.
ABC timing cap for the RF stage.
Yeah, that's
right. But if you follow the wire across,
yeah,
isn't that the AGC line?
Yep.
That is the AGC line. Yes.
And the other line is the 0 volt line. So I'm thinking that if you lose that filtering there, you could get oscillation coming back through the AGC line.
Well, also, if you lose the cap, it will give you zero bias, zero negative AVC bias on the IF and the RF and converter. So that would, of course, increase the gain, and you might get oscillation from the increase in gain. But a good design, even if that voltage goes to 0 volts, it shouldn't oscillate.
Yeah, but I thought maybe a strong signal would override, anything that was going on. So that's all. Just was thinking about that.
If it's leaky, it would take away the negative AVC voltage and increase the gain.
Maybe oscillate.
Yeah,
I was thinking open.
Okay.
It's always a 0.05, no matter what. That's the rule of thumb.
Yeah.
Those damn 0.05s.
Yeah. One thing I didn't understand that didn't look right to me is you notice this oscillator coil, the only direct connection is to the ABC line. And I guess there's a little loop of wire. It's capacitively coupled maybe from the grid of the oscillator to the oscillator coil. Is that the grid? I can't even read what it is there. I need a better schematic.
Well, funny, there's another footnote. There's another footnote down the bottom that talks about poor sensitivity and the set fails to operate on low frequency end of the dial, replace the oscillator coil.
Yeah. Yeah.
So between that 470K resistor at the first IF transformer and the oscillator coil, these notes are kind of like, here are 3 problems that we know about but have not fixed. So, take a look at these. Like, there's distortion and poor sensitivity caused by a short between turns on the wave magnet because we didn't really make it very reliable. Poor sensitivity, replace oscillator coil because we didn't make very good ones of those, and add a 470K ohm resistor across the secondary of the first IF because we should have, but we didn't. I mean, it's crazy.
Yeah. Well, what I'm going to do is I'm going to take your suggestion of switching the two 14C7s correctly this time, just so that
if we get a different problem.
Not yours.
Oh, I'm
close
going,
the loop.
the winds are really rough. Are you hearing them?
Sure.
Oh, okay.
Yeah.
Right. How was your meeting?
Wonderful.
Good. Okay.
Yeah.
So I'll see you upstairs.
Okay. Sounds good.
Don't forget the whipped cream. Sorry.
Try the veal.
Yeah.
Okay, we'll try this just to see what happens.
Was this a free radio or did you pay for it?
This is a free radio.
That's free.
I mean, you got nothing to complain about. That's good for a free radio.
You should have seen the 6 I brought home. They're terrific. Oh, terrific. I mean, the cabinets are great.
Keeping 2 dozen guys entertained for 2 hours too. What a deal.
We're easily amused.
Old radios are your best entertainment value.
Listening to them or repairing them?
Listening to them. Listening to someone else's.
Well, the local oscillator is working all the way down to the bottom of the dial, so we don't have that problem.
All right.
Show you something neat here.
I don't hear any stations like I did.
Yeah.
Before,
Oh,
Yeah.
your
the
toy.
Tiny SA.
Tiny SA.
I've got one of those. Everybody should have one of those. They're cheap. Especially if you ever worked for Hewlett Packard, because it's basically a 8565 user interface.
I have to get one of them because all the people I know have them, love them.
I used it to diagnose which TPMS sensor was no longer transmitting on my wife's car, making the tire light go on the dashboard.
Well,
Larry, you want to speak up so the video switches back to you?
Yeah, okay. I'm just trying to see if I can get the local oscillator signal strong enough. I think I found it. It's not real strong in the Tiny SA, but yeah, it's moving. See that peak moving?
Yep.
Oh, yeah. Mm-hmm.
That's the local oscillator.
Hiring yet another dirt. You have to fire him up because he shows up drunk. ZipRecruiter.com/Jesse. We'll be back.
That sounds like.
Well, that was entertaining.
Yeah.
Wherever that station was.
Yeah.
Canada.
That just demonstrates one use of the Tiny SA. You can see if your local oscillator is working across the band. So I think the rest of this is going to getting this to really sound good is going to require just some noodling and maybe just saying, oh, the hell with it. I'll start replacing capacitors and measuring some resistances and stuff like that. But I don't know. You guys want to have anything else you'd like me to try?
Well, can you run by what you're hearing in the way of the noise that it's making again? Because it's not coming through on the video at all. So is it a constant heterodyne kind of thing, or is it random?
No, not a constant heterodyne. Just I wish you guys could hear it over here because I can't imitate it. It's more like a static white noise competing with the signal, and it's everywhere across the band. It's not frequency dependent.
So that's those are not automatic transformer IFs, right? Those are old style with a real tuning capacitor in them, right?
Yes.
Yeah. So it's not silver mica disease. So that probably means
sound like silver mica disease. I know what that sounds like, and
no thunderstorms, no crashing.
Yeah, it doesn't sound like a lightning storm.
Yeah.
Yeah. Well, I suppose that might be a bad carbon resistor.
Could be. Yeah, you haven't measured all those. Yeah, forget about the wax paper capacitors. It could also be, I start with the highest wattage resistors and measure them and see if they're still anywhere near what they're supposed to be, and then work my way down to the quarter watt ones. But
just replace them all with bus wire.
Reohm them.
You know what we could do? We could fire up the signal tracer and go from the.
Oh, there you go.
Yeah, I was wondering, do you have one that has the, the noise test where you put voltage on the probe?
I do, but
the other brute force approach that I have used in the past is to start at the audio section and work backwards with like a little iPod or a cell phone or whatever, and I just inject an audio signal into the audio stage, and if it comes booming out of that speaker, I know my audio is fine, and then I know it's got to have something wrong with the RF or the IF.
It's kind of like taking your radio and splitting it in half. So you have like your RF and IF section, and then you have the audio section.
Yep.
And I love what Noah's saying is you just confirm that the audio is good, and then go back a stage at a time.
Yep.
And see where you end up.
Yeah. Well, we know that I've used that technique many times, and it's great for a dead radio. For isolating this noise, we know when we turn the audio, the noise comes and goes with the audio gain control. So we know it's before the grid of the 12SQ7.
Okay.
Already. So it's being generated somewhere in the RF portion of the set.
All right, so all you have to do is get the little Bluetooth chip and hook it up to the 12SK7, and you're all done. Just make it be a Wi-Fi radio.
That's law number 2.
No one wants to listen to AM anyway. So there we go.
I'm glad I've got to go around and unplug my signal tracer because the board's not going to reach otherwise.
Okay. No problem. Take your time.
The only thing with this, I wouldn't be surprised if after replacing the filter capacitors, if that motorboating issue went away. I say this because I had a very similar problem with that Howard Jr. set. This is the one that I had up at Brookline, where I had the motorboating and put in a filter capacitor and took care of the whole thing. And what I think was happening was I was having basically interstage interference because I didn't have that filter capacitor. So just something that I have had happen before with that particular type of sound.
You're talking about the main electrolytic or
Yes, actually, I am.
eyeglasses? Okay.
I am. I mean, I know that sometimes there's a lot of bypass capacitors that will also eliminate it, but I have had on, like I said, on more than one occasion when when the filtering isn't good enough in the power supply. Um, in the case of this particular last set that I worked on, I put the filter capacitor actually in the wrong place, and that kind of did it.
Okay, so I'm warming up the signal tracer here. Yeah, you can eliminate audio motorboat, or let me rephrase that. A poor filter capacitor can definitely cause audio motorboating because the filter capacitor acts as to keep not only 60 hertz, but other AC frequencies off of the B plus line.
Yeah, and if it's not really doing its job, and I mean this radio only has what, like a little 5-inch permanent magnet speaker. I mean, I don't know how much 60 cycle or is it really going to reproduce. There might be, it might not be doing its job, and just you can't hear the 60 cycle that much because it doesn't have a big 12-inch Zenith speaker hooked up to it.
That's a good point.
Hum could be there, but it might not be reproducible.
Our set's warming up again. It's almost like a motorboating type thing. I don't know if you hear that.
Yeah, unfortunately not.
So let's see.
There aren't any tube shields missing or anything like that, right? That's a pretty obvious one.
So let's go to the grid of the first IF tube, which is pin 6. Okay, so the first IF tube is here. Looks like 1, 2, 3, 4, 5. Super. 6 is the hardest one to get at.
Pins are counted clockwise from the bottom of the set.
Yeah, right. So this is 1, 2, 3, 4, 5, and 6 is under that capacitor.
All right.
So that must be the failed capacitor. So once you change that one and get it out of the way, it'd be perfect.
Let me see. Turn the gain down here. See if I can get it in there. I'm going to power down the radio again. There's a wire. It's not going to let me get to it. I'm going to have to move it out of the way. It's a ground wire. Just bend it up a little bit.
That was not me. I did not do that.
I powered down the radio when I did that. All right, so I'm powering it up again, and when it warms up, should be able to get to that grid. Make sure it's making the noise here. Warming up. Yeah, it's making obnoxious noises. Let's see if we can hear it out of the signal tracer. We're getting the hum. Let me see if I can get rid of that by changing the polarity of the cord on the signal tracer.
Just remote, we were able to hear that.
Yeah, I think if you want to get rid of the hum, you have to forget about reversing the plug on the signal tracer, replace the filter.
It probably isn't going to make that much of a difference since it's capacitively done, but the chassis isn't the ground.
Right. It's, yeah, the chassis is like B minus, I guess is the nomenclature we would use.
Right, but the tracer's ground loop is going to the chassis.
Yes.
Should be ground for RF anyways. Okay, that's definitely better, but I hear the noise there. So it's getting into the grid of the first IF. Let's get back to my schematic here. And see if, I mean, I don't know if I'm going to hear anything at the grid of the converter, but we can try that. That would be pin 6 again. The mixer grid is pin 6. So that tube is here. So let's see, you got 1, 2, 3, 4, 5. Why do they always put these grids buried under the capacitor? All the other grids are nicely accessible. But let's see if we hear anything there. Be a much weaker signal if it's there, so I'll turn up the signal tracer. Okay, well, I'm hearing hum, but I'm not hearing that noise. I'm not sure if it's just that it's weaker at that point or it's really not there. But my guess is it's somewhere in the converter stage where that noise is being generated. Not the IF stage.
Is it okay to try the plate?
Yeah, I think I'm capacitively coupled here in the signal tracer. If not, we'll find out.
You should be. If the little switch is in the RF position, I think you should be.
Yeah, it is. Since I'm probing RF, that's the position that I've been using. So the plate is pin 2 of the mixer. So we'll go to pin 2 of the mixer. But, you know, if we're seeing it on the grid of the first IF, it's really got to be on the plate of the mixer as well. So that, let's see, is that right?
Makes sense, but
Pin 2 is 2. This
You need your line.
Yeah, okay. I'm looking at the wrong tube. Okay, so we want the mixer. The mixer tube is here. That's why it didn't make sense. Yeah, okay. So pin 2 is here. Yeah, the signal is there and the noise is there.
but not on pin 6 of that tube.
Pin 6 is what? The grid?
The grid.
Yeah, let me go to pin 6 and we'll see. 1, 2, 3, 4, 5, 6.
It wasn't.
Hard to tell because I'm getting a lot of AC hum, but I hear a little something, but Now all I'm really hearing is hum, but you're not going to have the conversion gain
Right.
either. So yeah, I mean, I think it's a lot more likely it's coming from the converter than the first IF.
Okay.
And if I had another 14Q7, I'd try that before I tried anything else, but I don't.
I know I've got this thing about the AGC line. Is there any possibility we can find where the AGC line is and see if the RF tracer is showing it on
Yeah.
that line?
Absolutely. Absolutely. Matter of fact, it should be, if we go to the loop antenna and figure out which, I'm going to power down the set so I can flip it over.
So I'm unfamiliar with this stuff. The converter has gain.
What's that?
Does the converter actually have gain?
I'm assuming it does, but I don't know that for a fact. Okay, so, I found the ABC line. Gonna power it back up. All I'm getting is a loud hum when I put it on the ABC line. But I'm definitely hearing some squealing and just on certain signals, though. Just for yucks, I'm going to go to the audio, pick up the audio with the audio gain pot and see just what things sound like there. Probably get the loud hum again. Okay, so basically I hear the same thing out of my signal tracer that I'm hearing out of the speaker when I go to the wiper of the audio gain pot. So the audio section seems like it's not creating any problems. So anyway, I don't know if anybody has any ideas, quick things to try, we can do it. Otherwise, I'm just going to have to
We'll
spend some.
tune in. We'll tune in again in 2 weeks when you fixed it, and you can tell us.
Right, right.
All I need is another project, but okay.
Well, you have a couple options, Larry, because you could, if you wanted to continue this, you don't have to. You either want to go to the next meeting, or we could wait to the meeting that follows. It gives you a little bit more breather time, because 2 weeks can go by quickly. If you wanted to sort of pick this up if, where you left off.
Yeah.
Yeah, that sounds good. Give me a couple weeks, and I think we've got plenty of items to auction without doing this one this time. It in case it has to wait longer, but I just don't want to get into a complete recap and all of that because I really don't want to devote that much time to it. But I can sniff through it on my own time and see what I can find. I mean, it's not that complicated a radio. It shouldn't be that hard to track down.
Sure.
What do other people do? One of the things I would do is just to walk around the tube pins and check the voltages.
Yep.
Oh yeah, sure. Let's do that. Do we have a voltage chart?
All right, I didn't mean you had to do it now, but yeah, it's listed on the schematic.
Yeah, actually,
I guess as well with a scope. But I don't know if the signal levels are big enough to look at with the scope. I wonder if you could see the noise with the spectrum analyzer.
I doubt that, but I can try to fire up the scope, and I had that idea, but my concern was the same as yours, Hugh, that we wouldn't have enough signal to show much.
Right. Yeah, no, I was just talking in general. I wasn't really pointing you at doing things now, just people's debugging strategies for stuff like this.
Oh yeah, well that's probably one of the first things I would do. So let's go ahead and we can do that. And we don't have a voltage chart, but we should know, approximately what the voltages should look like at the plates and screen grids and the cathodes.
Yeah, there are voltages on the schematic. I see some 5 volts and some 54 volts and some 103 volts and 4.5 volts. And so there's definitely 33 volts. There's definitely -1 volt.
Yeah, just starting with pin, they're definitely on the schematic.
Yep. Okay. Well, I'm warming up my VTVM so we can do the control grids. The Simpson 260 will be fine for the screen grids and plates.
Oh, look at that masterpiece.
I mean, I know it's not.
Ooh, that's a nice one. You don't see the rack mount version very often.
See that.
Okay, so does it say where the voltages are measured from?
Yes. All voltages are measured from common return to points indicated with an AC, DC, or VTVM as required.
So the minus of the filter capacitor is...
Yeah, the minus of the filter capacitor is basically B minus.
Yep, well, that would have been my guess. It's a little more difficult than the chassis, but to get at, but we can get to it.
The more we ooh and ah about your cool test equipment, too, the hotter your wife thinks you are,
I tend to emphasize the terrific prices that we get from member Joe Coco for the replacement of the wax paper capacitors and say, look, I only spent like $4 on the capacitors to recap this whole thing. Doesn't it sound great?
Really?
So it's your cheapness that's attractive. The attraction.
Yes. But she likes when I'm cheap when it comes to fooling around with these stupid radios.
Okay.
Like, you spent $75 on fixing that and it gets AM. What are you doing?
And there's the rolling pin effect that follows.
It's really how much it costs for how much time it keeps you out of her hair is what it is.
Yeah, though she's got no problem with the time. It's like
it's the journey, not the destination, that's important.
Exactly.
Okay, here we go.
So here I am warming up. We'll start with the RF tube.
Seeing all those nasty little yellow tubes.
So the screen grid is always pin, let me see here, pin 3, and the plate is always pin 2.
Looks like it.
So I am going to get a piece of scrap paper so I can write these down.
Write them on the schematic. It's like writing in the phone book. It's okay. It'll help you when you're looking at the circuit too.
Okay, so RF tube. So we're going to be looking at pins 2, 3, 6, which we're going to look at with the VTVM, and 7, which is the cathode. All right, so the radios are warmed up here. The negative of the meter is connected to the negative lead of the filter condenser. And here we go, pin 2, which is the plate of the RF tube. No, that's the oscillator tube. That wrong tube. Okay, here's, yeah, here's the RF tube. Okay, so pin 2. Pin 2, the plate is only giving us 50-volt scale, only giving us 33.5 volts.
And it's on the schematic, it says 33 is what it ought to be.
Oh, really? That low?
Yeah.
Yep.
Holy crap.
All right.
It's dead nuts on.
Yeah.
I'll be dipped. I would have expected more on the plate. Screen, maybe, but not the plate. Okay. Here's the screen. And I see 36 volts on the screen.
That's too low.
Yeah.
It sort of looks like 85.
Yeah,
but
85.
I read it.
is what ought to
Must be 85.
Okay.
That's a problem.
Yep. Okay, I got that circled.
That's a filter capacitor.
Probably.
Well,
Unless it's not through a resistor.
Yep.
I'm going to jump to the plate of the 50L6 because that should actually the screen of the 50L6 should have full voltage.
That ought to be tricky because there is no 50L6.
Okay.
35L6.
L6, never mind. Same thing.
All right.
It's okay.
Huh. I have the green tied to the plate. They're operating as a triode. That's not what's on the schematic, but that's what's in the radio. Oh no, zit, wrong tube, sorry. That's the 12SQ7. Okay, so we went for and jumped.
That would be page 2 of the schematic looked at upside down.
The plate of the 35L6 ought to be like 103 or 105, something like that.
I think that's 103.
This is the screen grid, and it looks way too low to me. What's it say for the screen grid? Because I can't
85 volts.
85.
Yeah, okay. We're only getting about 37.
Yeah, it is the filter cap then.
And on the plate, we have about 41.
Ugh.
Oh man.
Change the electrolytic.
Found our problem.
It's amazing it's making any noise, huh?
Is the rectifier like glowing red or anything?
No, and the filter capacitor is not heating up appreciably. Just the heat from the tubes. So anyway,
Well,
I,
I mean, it goes back, step one, I know we'll get into that whole repair versus restoration thing, but like step one, change the half-century-old electrolytics.
yep. Well, you'd be surprised how many radios in my basement are still working flawlessly with either the original electrolytics or electrolytics that were installed in my childhood, which is, I hate to admit, was some time ago.
Well, actually, the one thing I like about this exercise is that you actually derive the problem area. So it's maybe it maybe is pointing to filter cap, but we sort of found out, how you got to that conclusion.
Yeah. I mean, that's pretty much the only thing that could be pulling down the voltage. I mean, there are some resistors.
There are some resistors. There are a couple of 470 ohm resistors.
Well, to the plate, to the output transformer, okay, there's a 22 ohm wire wound R11.
Yes.
So not going to cut much voltage across a 22 ohm resistor unless it's greatly increased in value, which you usually don't see on wire wound resistors.
It's weird though, because it's it could be a typo. I don't know. We're talking old documentation, but R11 is that 22 ohm wire wound. R12 is a 470 ohm, and R13 is a 470 ohm, and they're all kind of tied into the filter network, but they're all somehow rated at 1 watt. But those are the highest wattage rated resistors in the whole set. So, they're under the most stress, quote unquote, compared to everything else.
Yeah. But
it certainly would be worth measuring their values to see.
They like the drift at the 470 keys.
I think there's another. What's R9? I got to look at R9. Well, that's only a half watt, but it's 150 ohm wire wound. I'm always suspicious of wire wound resistors. I don't know why, but.
So it almost looks like they used part of the output transformer as a filter inductor.
Yes, they did. Actually, it says that in the notes. They actually did that. It's not center tapped, it's offset, and it's supposed to do something about the frequency response. You got to kind of the rest of the cliff notes.
So I'm going to just take some readings right at the filter cap. I don't know which terminal is which, but I'm going to try to get all of them to take that resistor out of those resistors out of the equation. So at one terminal, I'm seeing about 35.5 volts. Another one I'm seeing about 38.5 volts. And the other one I'm seeing about 41.5. So 41.5 is the winner, and it should be a lot higher than that.
Yep.
So
you did say you tested the rectifier and got good emission, right?
Yeah, the rectifier tested on a Hickok 538 transconductance tester. So, of course, in a rectifier, you're not looking at transconductance anyway, but it tested good for a rectifier.
But all three of those filter caps come after the 22 ohm wire wound resistor R11.
Yes, they do. So, but
either that's really big or something I would think would be getting hot in here. Maybe the tube. Maybe the tube.
It's no hotter than I'd expect a 35Z5 to be, but
you measure the voltage on either side of that 22 ohm wire wound resistor?
There's an idea.
Well, I just measured it on one side.
That's true. You did just measure it on one side.
I just I can do the other side, but
The other side, though,
the other side's the cathode of the tube.
right?
So let me measure.
That should be 110.
Let me measure the resistance directly here.
I'm assuming you're powering it off first.
Yes, I'm powering it off. Okay, so there's the R times 1 scale. We're powered down from the power strip. I'm going to go from...
Still a charge on those electrolytics. So you should wet your fingers and make sure you discharge those first.
Yeah, that's a great idea. Or use your tongue.
Yeah. It's not going to be much. Certainly nothing you haven't felt before.
Here, what I'll do is I'll discharge it through that 8 ohm resistor. I'll go...
yeah, there you go.
I'll go to the cathode. I'll go from negative to the cathode, which is pin 8 of the 35Z5. No spark. So it's discharged. Now we'll go from the pin that gave me the highest voltage, because that's going to be the one that's
first in line.
First in line here. So that's here. And we'll go aha. Oh, wait. No, 20 ohms.
Huh. Okay.
So the filter capacitor almost has to be what's pulling it down.
Yep.
Mm-hmm.
Yeah, well, a voltage measurement would verify that.
Okay, boys and girls, it's been almost 2 hours here.
Yeah.
Yeah.
We know what we have to do, and probably that
get yourself a couple of 20s and a 40.
Yep. Well, I've got a 47. That's as close as I had to 40 at 250 volts. That should work fine.
Yep.
And I've got a couple 22s at 350 volts. So
Perfect.
That's the closest I have.
Close enough. You don't have to restuff the can for us. You can just stick them in anywhere you want.
Especially since the typical tolerance was minus 20% and plus 100%.
Yeah, totally doesn't matter.
The only one that's critical is on the input side of a capacitor input filter, because if you make that one too big, I'm talking, 2, 3, 4x the design value, you can draw excessive currents through the charging currents.
Yep.
But
that's why before the first section they have that wire wound resistor that could handle that, maybe, if that happened. But
yeah, that's a filter resistor, no doubt.
Can't be any worse than the current being drawn now.
Right. Exactly. Cool.
That was terrific. I mean, really terrific. I have to thank both you, Larry, and Elaine for hanging in there and going in different directions. But this was a really brilliant idea.
Let's have a big hand for Elaine. She's
Thank you.
A lot of things. Some what I can understand.
Okay. Well.
Well,
thanks everybody for humoring my efforts here.
Oh no, it was a lot of fun, and
Wonderful, Larry.
It was a great way to do it. And Larry, you can think about what you want to do if you want to do the caps, as another meeting, and then see where we left off. We are at the cliffhanger. Dun, dun, dun.
I think he should just send it to Santa up there in Vermont, and then
yeah, he's got to reohm it.
Yeah. I have plenty of marshmallows ready.
and we get
and a fire suppression
I was
system.
going to say we get to have a demo.
John, I think that that we might really all enjoy another thing, and that is a walkthrough of a schematic. Even this schematic, if somebody would just start out at the antenna and walk us through, there are a couple of strange things, the feedback circuits in the audio of this radio, that I'd love to have explained to me. And if we did it sort of as a group endeavor, people could chime in and explain things that other people might not know.
Yeah,
Or
somebody, I mean,
yeah.
look at the I think you're right, Tom. Look at the converter tube, the 14Q7, and I can't see what it says, but I think it's tied to the grid like G0. You come down and you go through a 220 ohm resistor labeled R2 to like some pigtail that goes nowhere. What the hell is that?
Yeah. I think that is put there to confuse us.
You know, stuff like that is just mystifies me. I mean, it's just crazy.
Yeah, based upon the turnout of this particular meeting, I think Tom's got a great idea there, and maybe we should devote a meeting to that.
Yeah,
and,
absolutely.
I think it would be great for everybody involved.
I'm
We
wondering,
could even use this schematic, or maybe somebody would find one. Maybe if none of us understands this one, we should start with a different one.
Start with one that makes sense, and then maybe when we all get educated, we can figure out what the hell they did with this. But
Yeah. Is it the oscillator coil that the question is on?
Yes.
And the oscillator coil, could that just be a gimmick? Like the
that's
capacitive coupling?
That's a whole webinar in itself of what is a gimmick. You know, that's
yeah, no, that's what I thought. It has to be a makeshift capacitor, but why?
But why?
Well, it's on the oscillator coil if you look below, right?
Yeah,
well,
it is.
But it's not part of the oscillator, is it? I don't know. It's just kind of.
It is. It's built down to it. If you look on the oscillator, the outline of the oscillator coil a little below that on that page, it shows a fifth terminal on it.
It has to be, because it's the only way that the secondary of the main winding, the tuned winding of the oscillator coil is coupled to the oscillator grid. Without that coupling, it won't oscillate.
That's the kind of thing that would be fun for us to work through together, I think.
Yes.
Absolutely. I'm all for using this, because this circuit has little quirky things like that. I mean, you know, just a straight
all over the place. Yeah.
If we were really good, we'd load Spice on our computers and plug these things in and go at it.
HP Spice.
Maybe people could have a homework assignment of finding interesting schematics for us to work through together.
I'll leave that as an exercise for the student.
There you
go. Yep. All right, great.
Well, this is many thanks, Larry.
We
can talk offline.
Brave
Everyone, yeah, exactly. You know, doing this live, you know, while you know, following our questions and opinions was great. You know, we really appreciate the effort you and Elaine invested here. It was thoroughly fun and got great attendance. The attendance is awesome. So, you know, we could talk offline if you want, how you want to use, if you want to use another meeting. You know, do you want to, you know, replace the filter cap and see life, or do you, which may not take a whole lot of time. Did we want to look at the schematics as another part of that segment of the meeting? We could do a number of different things.
Well, the nuts and bolts of replacing the filter cap, I prefer to do on my own time, because, you know.
Yeah, that's true. It's probably.
But if you do that and it fixes everything, then that's all you have to let us know. You know, so that's
yeah, that'd probably be enough, actually.
That's going to be time consuming, and I don't want to take up Zoom meeting time for that.
Yeah, it's like watching grass grow or the New York Jets play football.
Or you could cut the dial cord.
There we go. Yeah, let's redial it. I mean, restring it.
That would be fun to do an alignment, though. Huh?
I'll leave that for an expert in that particular.
Right. Well, this is great.
That's great.
We can we decide is if there's any, any follow-up meeting even warranted, you can decide that, Larry. We could talk. You didn't have to plan for the next meeting. If, I'll leave it up to you as you think about it. If there's anything we want to do here, or we can go look at the schematic as a post-mortem.
Well, we're going to do the next meeting in 2 weeks, right?
We can do it we can do it the next meeting if you want to. That's absolutely fine. Or we can do it the meeting after. I am flexible either way. I want to give you enough time you don't feel burdened that you have to rush and make sure you're ready for the next in 2 weeks because they can go by in a flash.
The choices are 2 weeks or 4 weeks or
Yes.
6 weeks.
Right.
Yeah. I can do 2 weeks. I don't want to let too much time lapse, and
Okay.
I need to get on to other projects, so that'll motivate me to get this one done.
That's absolutely fine. Completely at your discretion.
Yeah. Okay. So let's do this again in 2 weeks, and I'll have filter caps installed and maybe a little more troubleshooting done just to save time, but if it needs it.
Sure.
Just don't.
Hey, wait, George, did you have something you wanted to say, or was that a clap?
I
Oh, okay.
was going to say, if you could post the tube number that's weak, maybe one of us has one that we could send to you.
Tube.
Yeah, I was actually going to ask that anyway. Let me do that.
Yeah, to shoot a flare over the group's IO.
Here, I'll post it right now. And I'll do that too.
And then after we do about 8 or 10 more of these, we can have Ross take us through a German radio.
And then I'll take you through an Enigma machine. What the
heck? I've seen that movie, Tom, and I'd like to see it again.
And then I'll set up a set of cross rams on a 413 from 19.
That's a nightmare.
Well, it's just like a German radio. When it works beautifully and fantastically. When it doesn't, you want to rip your hair out.
Yeah, my brother.
What tube are we looking for?
What's that? 14Q.
413.
I just put that box. 14Q7.
Okay.
14Q7. Okay.
I shall wander out to my drugstore tube tester with its drawers full of weird tubes down below and see what I have.
All right.
This is the first time I've ever encountered one. I don't have a lot of loctals, and most of the loctals I have are the 6.3 volt ones. I've got a few of the 1.4 volt battery tubes.
Yep.
But only a couple 12 volt tubes, and they weren't 14Q7s.
Well, if you're struggling with the 14Q7 and you've kind of figured out that maybe it's no good, for grins and giggles, just as a temporary quick thing to try it, throw 7Q7 in there. Even though it's a 6 volt tube and just same tube. See if it,
the problem is
it works.
So it's it's not going to light very bright, may not get enough out of it, and all the other tubes will be overstressed.
Yeah, but you won't have to worry about the power transformer.
Right.
That's true.
So anyway, thanks.
All right. Well,
thanks everybody.
Nice job, Larry.
Yeah, really. Thank you very
Good
much.
job.
Really, really appreciate the fantastic job you did. And thanks everybody for attending. Really made for a great discussion. So on the interim,
John, when you put this up and announce the recording, you might give a little more of a description for people, because this would be a lot of fun for people. And they see you put up a recording, but I'm not sure they know what's in it. And this one, we have some real serious content.
absolutely fine. I can do that. I guess what I do is
kind of title of how to troubleshoot a radio. That's what brought everybody in the first place.
With a schematic link.
Yeah.
Well, Right, I can
Yeah.
do that. In fact, actually, a couple of things I can do here is that what I do, and I guess it's probably good feedback, is when I post the meeting after after the recording, I don't bother repeating what the meeting was about historically, but I suppose I should. I assume that people might have remembered what the topic was before, but I guess I really should going forward. So
Well,
people
it's
know.
for those people who weren't, attending
Oh,
and
sure. Right.
learn the newbies and
Right.
edit out anything I said as far as this.
Well, yeah, I gotta have to go beep, beep.
Well, thing going is a filthy mouth.
But yeah, yeah.
Do not try this at home, children.
Yeah, exactly.
Yeah, everyone's going when you hear them know speak.
We'll do another one in a couple of weeks. I could show you my collection of mattress tags that I've pulled off,
Right.
all those other little tags. No user serviceable parts inside. Refer servicing to qualified service personnel. It's like, fuck that.
Well, there we go. There's my first beep. But that I will do that going forward. And actually, just as one final thing is, I'm going to be partitioning our notable video section on our website to go from just notable presentations to training. I'll have a training subpage. So this will be put on that, and as well as obviously the reoming one. But but no, I'll do that. You'll see that work. But that's the good feedback. Thank you, Tom. When I post something, I will tell people what the topic was in case they care. This one obviously being one such.
Right.
All right, boys. I really appreciate you guys attending. Really enjoyed your feedback and the conversation. And we'll see you in 2 weeks, either with Larry, or if Larry wants to hold off another 2 weeks, and we'll have a round robin.
Great.
All right, guys.
Thank you.
Take care of yourselves.
Take care.
See you later.
All right.
Bye.
Bye.
Bye.